Active learning with data streams. Active learning is a machine learning approach where the model actively queries the user or makes its own decisions to select the most informative samples from an unlabeled dataset to label and incorporate into the training set. This process can greatly improve model performance with fewer labeled instances. In this part of the tutorial, we focus on stream-based active learning, which involves learning from data streams in real time. 1. Stream-based active learning. Stream-based active learning operates on data streams, where data arrives sequentially and can be accessed only once. Unlike traditional batch learning, stream-based learning requires algorithms that adapt to the changing nature of the data and make real-time decisions. It is particularly useful in scenarios where data instances are expensive to label or labeling is time-sensitive. 2. Data stream characteristics. Before delving into stream-based active learning algorithms, it is important to understand the characteristics of data streams and how they affect the learning process. Data streams pose unique challenges such as concept drift, imbalance, and limited resources. Concept drift refers to the change in the underlying data distribution over time, which can make models outdated if not adapted accordingly. Imbalance occurs when the distribution of class labels is uneven and requires special techniques to handle. Limited resources, including memory and processing power, further add to the complexity. 3. Stream-based active learning framework. To effectively learn from data streams, a stream-based active learning framework is essential. This framework typically consists of 3 key components: an online learning algorithm, an uncertainty or diversity sampling strategy, and a stream management module. The online learning algorithm continuously updates the model as new instances arrive, while the sampling strategy selects the most informative instances for labeling. The stream management module handles the data stream's characteristics, including concept drift detection and adaptation. 4. Active sampling strategies. In stream-based active learning, selecting informative samples is crucial for maximizing model performance with limited labeling resources. Various sampling strategies can be employed, each with its own advantages. Some popular strategies include uncertainty sampling, diversity sampling, committee-based sampling, and active learning by disagreement. These strategies aim to select samples that are difficult or uncertain for the current model, promoting further improvement. 5. Adaptive classifier design. Designing an adaptive classifier is crucial in stream-based active learning. The classifier should be able to adapt to concept drift and handle imbalanced class distributions. Techniques such as ensemble methods, concept drift detection algorithms, and instance selection can help improve the model's performance in evolving environments. Additionally, feature selection and extraction methods can reduce resource usage and improve efficiency. 6. Evaluation metrics. Evaluating the performance of stream-based active learning algorithms is essential to measure their effectiveness. Common evaluation metrics include accuracy, precision, recall, F1 score, and area under the receiver operating characteristic curve, AUC-ROC. These metrics enable comparison between different algorithms and help determine the most effective approach for a given dataset and problem. 7. Implementing stream-based active learning. To implement stream-based active learning, various machine learning libraries, such as scikit-learn, TensorFlow, or PyTorch, can be used. These libraries provide a wide range of algorithms, data preprocessing techniques, and evaluation tools. Additionally, frameworks like Apache Flink and Apache Spark Streaming can be utilized for efficient stream processing. Stream-based active learning is a powerful technique for learning from data streams in real time. By actively selecting informative samples for labeling, it can improve model performance with limited labeling resources. Understanding the characteristics of data streams, employing appropriate sampling strategies, designing adaptive classifiers, and appropriately evaluating algorithm performance are key to successfully implementing stream-based active learning. Remember to adapt your approach based on the specific requirements of your dataset and problem domain to achieve the best results.